Hey everybody, this is Mrs. Harding. I'm going to very quickly take you through the beginning half of this note sheet. So make sure you have the note sheet in front of you. What we're going to start working on the next unit, Unit 2B, is complex numbers, solving quadratics, solving radicals. So the first thing that we need to talk about is what I is and what an imaginary number is. If you haven't worked with I before, I is the square root of -1. That's how it's defined, and that's just to help us deal with square roots of negative numbers. So we're first going to take a look at just some manipulating and some different exponents on I. So I squared, well, that would be the square root of -1 squared, which is just -1. So we often use that fact right there, that I squared is -1. What if we kept going? Well, I cubed is I times I squared. And we already know that I squared is -1. So I to the third is negative I. You can kind of use this idea that I squared is -1 to evaluate even larger exponents. So think about here, I to the 24th. Well, I to the 24th is really I squared to the 12th, if you remember your exponent rules. So what is that? -1 to the 12th. -1 to an even power is going to be +1. So I to the 24th is +1. How about I to the 17th when there's not an even power? So you could just write it as I squared to another power. What you want to do first is let's just write this as I times I to the 16th. So then we can break it down into I times I squared to the 8th. I squared is -1. -1 to the 8th is going to be +1. So this answer would be just I. When you're doing I to a certain power, there's really only 4 possible answers. It's either 1, it's -1, it's negative I, or it's positive I. How about I to the 54th? Well, this is an even number, so it's I squared to the 27th. -1 to an odd power is going to be -1. I to the 103rd. Well, remember what we did with that. I times I squared to the 51st. Do you see how we broke down 103 into those numbers? First, I peeled off an I to the first. That would leave me with I to the 102nd, which is 2 to the 51st. So this is I times -1 to the 51st. -1 to the 51st is just -1. So this is equal to a negative I. All right, so then how can you actually apply this to some square roots of negative numbers? Remember how you can split up square roots? I can write this as the square root of -1 times the square root of 9. Well, the square root of -1 is I, and the square root of 9 is 3, and so we write that answer as 3I. -48. Well, 48 isn't a perfect square, but splitting up the 48 into its factors still applies. So it could be -1 times the square root of 16 times the square root of 3. -1 is I. Square root of 16 is 4. So we're looking at 4I times the square root of 3. In fraction form, we're just taking the square root of the top and the square root of the bottom. So this is still square root of -1 times the square root of 1 over 36. So this is I. Square root of 1 is 1. Square root of 36 is 6. So this is 1/6 I, or I over 6. Last one, number 4. This is just going to take some thought of what the largest perfect square is that divides into 120. The largest perfect square that divides into 120 is just 4. So this is the square root of 4 times the square root of 30 all over the square root of 49 So we have an I, 2, square root of 30, and 7. The way you will see that written is 2I, root 30 over 7. Kind of a funny looking number. All right, those are imaginary numbers. We're going to talk a lot about complex numbers. And a complex number is any number in the form A plus BI, where A is the real portion of the number and BI is the imaginary portion of the number. So we've seen lots of real numbers before. 5, negative 3.2. And imaginary numbers, square root of negative 4 is imaginary, I is imaginary. All those answers we just came up with above were all imaginary. So then a complex number is the combination of a real number and an imaginary number. And that's going to be an important idea when it comes to doing operations with complex numbers. You can only add, subtract real numbers from each other and imaginary numbers from each other. So in this first example, I can add the real portions. So 8 plus 2 is 10. And I can add the imaginary portions, which would be minus 2I. Same thing with subtraction here. You just want to be sure that you're subtracting all parts of that second complex number. So then this is 2 minus 5I. For multiplication, it's going to look a lot like FOILing a binomial. We're going to go 2 times 4, 2 times 5I, negative 3I times 4, and negative 3I times 5I, which is negative 15I squared. Keeping in mind that I squared is actually negative 1, then I'm looking at 8. I'm going to combine these two imaginary numbers here. And this is actually plus 15. So the answer here is 23. That's the real part of the answer, minus 2I, which is the imaginary part. If you take a look at the top of the next page, there's a special type of complex numbers or special types of complex numbers that are called conjugates. So if you look at number 4, do you see how they have the same real parts? And then the imaginary parts are the same numbers, just one is positive, one is negative. And the reason that conjugates are important is because when you multiply conjugates, you get only a real number. So if we went through FOIL with this, you'd get 4 plus 10I minus 10I minus 25I squared. Well, these guys cancel each other out, and I squared is the same as negative 1. So this is really 4 plus 25 is equal to 29. So there you started with complex numbers that had an imaginary part to them, and you ended up with just a real number. And that fact comes in, whoops, didn't mean to show you there the whole bottom part. When you're looking at division, how do you actually divide complex numbers? You don't really divide in the sense that you divide other numbers, but what you do is you multiply the top and the bottom by the conjugate of the denominator. And that gets you just a real number in the denominator. So here in the bottom, I already know that negative 8i and positive 8i are going to cancel. So I'm just going to look at this, 16, and then negative 4i squared is going to be positive 4. Now in the top, I have to do the full multiplication because they're not conjugates. So 12 minus 6i minus 4i plus 2i squared. So let's simplify all this. This right here can be combined. And I squared is negative 1. So this is like 12 minus 2. And, oops, that's a negative, minus 10i all over 20. That can be reduced. There is a factor of 10 in every single term. So I'm going to cross all the 10s off. And this becomes 1 minus I over 2. But if we want to break this down into the real and the imaginary parts, then this is really 1/2 minus 1/2 I. Let me take you through one more of those in number 6. So if I want to do this division, what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the denominator, which is 3 plus I. So in the bottom, again, I already know 3i, negative 3i, it's sort of like the inside outside of FOIL. They're just going to cancel. So I only need 3 times 3. And negative I times positive I, which is negative I squared. We'll come back to that piece. In the top, I have 18 plus 6i plus 21i plus 7i squared. So in simplifying this in the top, remember I squared is negative 1, so this is like minus 7. 18 minus 7, 6i plus 21i. And then in the bottom, 9 minus negative 1 is 9 plus negative 1. Breaking this into the real part of the complex number and then the imaginary part of the complex number. All right, so I want you to try out the rest of those examples, and you can go into the daily notes folder underneath Unit 2B on Canvas to check the rest of your work. I will see you all tomorrow.